Good morning. This is Mrs. Mooring. Today we are solving ideal gas law problems for War Hill High School's great chemistry students. So here are our objectives for today. We're going to use PV equals nRT to solve with moles of gas. We're going to use PV equals nRT to solve with grams of gas. And of course, we're going to remember to convert Celsius to kelvins using 273 plus degrees Celsius equals kelvins. Now, before we get started, you need to have a calculator, a periodic table, and paper. So pause if you don't have those. You should have already watched Tyler DeWitt's video about ideal gas laws. We learned from him that we use the ideal gas law to solve problems involving moles of gas. P is pressure in atmospheres, V is volume in liters, N is the number of moles, and T is in kelvins. And again, we must remember to add 273 to the temperature in Celsius. Which brings us to the question, what is R? R is 0.8206 atmospheres times liters, moles times kelvins. Now, this looks kind of scary, but don't worry about it. The only part that you need to know is that you're going to use 0.08206 every time you need to use R, as long as your pressure is in atmospheres. So we're going to try some problems. Here's our first one. How many moles of helium will be required to fill a 16-liter balloon in Denver on a nice summer day at 0.819 atmospheres and 30 degrees Celsius? And Mr. PV equals nRT says, hey, kelvinate. So we're going to do that. So we write down all of our variables. We have that P is 0.819 atmospheres, volume is 16 liters, N is moles. That's what we're trying to solve for. R is 0.08206, and we kelvinated to 303 K. So we're going to substitute those values into the equation here, PV equals nRT, and solve. We need to isolate moles, so we're going to divide both sides through by 0.08206 times 303. It will cancel on the mole side. Then we can enter these into our calculator. You're going to multiply the top, then enter the divide button, add parentheses, type times 0.08206, end parentheses, and hit equals. And you should get that you get 0.526 moles. Now we're going to round to two significant figures using significant figure rules. You try the next one. You need your periodic table, you need a calculator, pause the video, and solve the problem. Okay, if you were right, you should have gotten 140 atmospheres. Remember, you needed to kelvinate, so if you got the wrong answer, go back, try kelvinating, see if that helps. All right, so we're going to write down the various values that we have. We have pressure, which we're trying to solve for, 25 liters, 139 moles. There's our R. We figured out our temperature in kelvins. So we plugged it into PV equals nRT. We isolated the P by dividing everything through by 25. And you should have gotten that P is 135.0 atmospheres, but we can only have two significant figures, so you should have calculated 140 atmospheres. Okay, we're going to ramp it up a bit. So here we go. We've got our equation, PV equals nRT. We've got our value for R over here. 13 grams of neon is placed in a 2.0 liter tank at 29 degrees Celsius. What is the pressure inside the tank in atmospheres? What do we do with grams? We convert grams to moles. So we're going to take the 13 grams of neon and we're going to use unit cancellation, periodic table value, to convert to moles of neon. Now we're ready to use PV equals nRT. So we write down the variables that we know. We plug them in to P times V equals moles times R times kelvins. We'll divide through by 2.0 to isolate pressure. And you should calculate that P is 7.98 atmospheres or 0.80 atmospheres with significant figures. You try. So you're going to need your periodic table. You have 4.00 grams of oxygen in a balloon at 38 degrees Celsius and 1.3 atmospheres. What is the balloon's volume in liters? If you get 2.5, you're correct. Pause to solve the problem and restart the video when you are ready. Okay, so first thing we needed to do is we needed to figure out how many moles of O2 we had. So we remembered that this is a diatomic, so the mass of oxygen is 32.00 grams per mole. And we discovered that N is 0.125 moles. And now we're ready to plug in. So the only thing that we have to solve for is volume. So we have our pressure, we have volume, 0.125 moles. There's our value of R. There's our temperature in kelvins. We have to isolate volume by dividing everything through by 1.3. And when we solve for volume, we have that volume is 2.45 liters or 2.5 liters with sig figs. Okay, we're going to try another similar problem. How many grams of xenon gas are needed to pressurize a 5-liter tank to 0.684 atmospheres at 55 degrees Celsius? So, Mr. Ideal Man says we find moles and convert to grams. So this time we're going to use PV equals nRT first and then solve for grams. So we identify our pressure, our volume. We're going to solve for N. R, we're using 0.8206, and we kelvinate our temperature. We have PV equals nRT. We need to isolate moles, so we're going to divide both sides through by 0.08206. We isolate moles. Moles is 0.127. Now we're ready to solve for grams, so we need the periodic table. We have 0.127 moles of xenon. The molar mass of xenon is 131.29 grams per mole, so we calculate that we have 16.67 grams of xenon. With 2 sig figs, that's 17 grams of xenon. Now it's your turn. So you have a 10-liter container. It's pressurized to 5.6 atmospheres with helium gas at 15 degrees Celsius. So how many grams of helium are in the container? You should get 9.5 grams of helium, so try this on your own. So pause and go on when you're ready. Okay, so you're going to write down what you know. You know your pressure, you know your volume, you're solving for N, there's your value for R, and you kelvinated your temperature. You plug it into PV equals nRT. We need to isolate moles, so you divide both sides through by 0.08206 times 288. Then you cancel out tops and bottoms where you can. And you have 2.37 moles of helium. And then we convert the moles of helium to grams of helium. We calculate 9.48 grams of helium, which rounds to 9.5 grams of helium. So we've done a bunch of problems where the pressure has been in atmospheres. How do we solve PV equals nRT problems when the pressure's in different units? Well, notice that part of the units here on R is atmospheres. If you have a different pressure unit, you can just go online and look up the value for R that is consistent with the new pressure unit. So here are two common values that show up. R is 8.314 if you're using kPa, and R is 62.36 if you're using millimeters of mercury. Now all your problems are going to be right here, so you just need to write down that R is 0.0826, but in the future you might run into problems where you are using kPa or millimeters of mercury. So let's take a look at what we did today. You used PV equals nRT to solve with moles of gas. You converted grams to moles to solve PV equals nRT. And you converted moles to grams to use PV equals nRT. Now, go solve some problems.